Hello everyone, thank you for joining me today. My name is William and today we're going to be looking at efficiency. So we have a few learning objectives and that's to define what efficiency actually is, to be able to understand that wasted energy is dissipated into the surroundings, to be able to understand how to reduce unwanted transfers, and to that efficiency percentage is equal to a useful output energy over total input multiplied by 100. So if you're ready, let's get right into it. Okay, so first we want to look at what efficiency actually is. So all efficiency talks about is the proportion of energy that is converted into useful output energy. So what this really means is out of all of the energy that I'm putting into a system, how much of it is actually useful to me. So a very common example of this is the filament bulb example. So we have in here an electrical energy store going into the bulb itself, and now the electricity passes across the filament here. The filament is a very thin piece of wire. Pass current through the wire, it starts to heat up. When it starts to heat up, it starts to glow, and that gives off useful light energy. But as a side product of heating, well, it also dissipates heat. So what we're really looking at is of how much electricity I put in, right? So let's write in here efficiency. Wrong. Oops. I am just going to give it the symbol to E, right? That's not a standard symbol, that's just something I'm doing it now just to save a bit of time. So out of all of the energy that I'm giving it, so electrical, just remember this is total input energy. How much light energy am I getting out? Because that's the useful output, light. Okay, so that shows you fraction of light energy out of all of the electrical input given in. Now you can see that there's an energy transfer happening here. So efficiency is always when we're looking at energy transfers. How efficient transfer process? So this would just give us here a ratio, right? A number from 0 to 1. But it's commonly easier to look at efficiency in terms of percentage. So all we do is that ratio by 100, and that gives us efficiency in percentage. Okay, that's really what efficiency is about. Out of all of the energy that I'm putting in, how much useful energy am I getting out of it? Now, actually happens to the useless energy, you could say, or rather the wasted energy. Now, from our law of conservation of energy, we know that energy can be created nor destroyed. So this heat energy that's given off, it doesn't just disappear. No, what happens is a very specific terminology that you need to start using is that, or whatever sort of wasted energy dissipated into surroundings. Okay, so anytime you have a question asking what happens to the wasted energy, you have to write dissipated into the surroundings. A lot of people just say, "Oh, it's wasted or it disappears." Completely wrong. You have to say it's dissipated in the surroundings. Now we want to understand how we can reduce wasted output energy that is dissipated in surroundings. Now, we understand that the higher efficiency, the better, right? Because you want to get the most, like the most bang for your buck for every joule of energy you put in. You want to get ideally 1 joule out, but in the real world, we can never really get 100%. We can just get very close to it by using two types of things, either thermal insulation or lubrication. Now, let's first look at thermal insulation because that's the more intuitive. Now, say we had our house, right? We have our heating, and it's the winter, right? So we want all of the energy coming out of our radiators stay within the house. Now, a few things that we can do to thermally insulate the house is have double glazing. Now, what is double glazing? Well, that's really where we have, say, the cross section of our window. So we've cut a window in half, like facing it, and now we're looking at the sort of thickness of it. Now, what double glazing really is that one pane of glass is here and another glass is here. Glass separated by a vacuum. A vacuum. Now, a vacuum is really a place where there's no particles, there's no air between these two panes of windows. That means that there's no particles to sort of conduct that energy away. Because remember, energy is really transferred by the collision of particles. So if there are no particles to actually collide with each other in between the two panes of glass, no little to no energy can be transferred across them. So we get a thermal insulation, right? We keep energy in. Now, another thing that we can do is to prevent our homes from losing heat. That's really just a layer of insulation in the actual loft itself. Layer of roof. Okay, so that a loft insulation is really just a very specific example of insulation in general. So insulation in general is when we use one material and we wrap another object in that material itself, such as if you were to wear gloves on a really cold day, you're insulating your hands against outside air. Now, this insulation itself is usually made of a very airy material such as cotton. Now, why do we use a really airy material? Well, because air is a bad conductor. So if air is a very bad conductor, that means that it can't really conduct a lot of heat away from the actual object itself. And so the heat has no other option but to just stay inside. It will be insulated. So airy materials have large pockets of air, and we also know that air is a bad conductor, so the air doesn't conduct the heat away, and so we get insulation. Now, double glazing, this a real method of putting a vacuum in between two layers, is also something that happens within flasks. Flasks such as like thermoses for like tea or coffee or whatever. Inside the flask itself, so let's draw a very simple. I have my outside here. Now inside it, I have this sort of inner chamber where I put my coffee, and this outer chamber here, this gap, has vacuum in it. Again, there are no particles in the vacuum, there's no way for the engine to spread out, and so our tea or coffee stays warm. So that's a thermos or a flask. Now, the second way is a lubrication, which really entails putting a layer of liquid. Sometimes it can also be a material such as like graphene, but that's another thing for another. A layer of liquid objects contact reduce energy wasted as work done against friction. Okay, so that's a long statement, but let's deconstruct that. Now, what lubrication in itself is putting a layer between two objects which rub against each other. So that could be gears or it could be hinges on your doors. So let's draw a very rubbish gear, really. Okay, I know that's not very good at all, but let's together anyway. Okay, that's my gear there. Right. Oh, actually, it kind of looks like a hinge. Let's change that to a hinge. That's my hinge right there. Now, I would put lubrication such as like oil or like WD-40 if any of you have ever helped your parents with like any sort of housework. You put that between two places where the hinges contact with each other. Now, or this sort of makes the hinge more slippy, right? That's not a very scientific word, but it's a very intuitive word. It means that they slide against each other really easily. Now, because they're sliding against each other, that means that there's low friction between the two objects. So that means that there's less and less wasted trying to overcome that friction. Because remember, make an object move first. Not only do you have to actually supply object to supply energy to keep on pushing the object, you initially have to overcome the sort of stickiness to whatever surface, which is called friction. Okay, so lubrication works by putting a layer of liquid between two objects in contact to reduce energy